Hi everyone, today we are going to discuss on computer system. So we are using William Stalling's 8th edition chapter 1 book. These are summarized notes. So we'll start with operating system. So we can say express the hardware resources of one or more processors and then provide a set of services to system and users, manages secondary memory input and output devices. So that's what the operating system can do. Another thing, we have basic elements. So we have about 4 basic elements, which is the processor, we have the input and output modules, we have the main memory, we have the system bus as well. So what is this 4 basic elements? So we'll start with the processor. So we can see that the processor, it controls the operation of the computer. The processor, it acts as the brain of the computer and then performs the data processing functions. So we can say referred to as the central processing unit, CPU. That's the processor. We also have the main memory. Main memory are volatile, meaning when electricity is lost, then everything, all the data instructions is what is lost. Content of the memory is lost when the computer is shut down. And then we have referred to as a real memory or primary memory. So this main memory are referred into 2 categories. We have what we call real memory or primary memory. So we also have the input and output modules or devices. So input and output modules or devices, we have what we call the storage, like the hard drive. We have what we call communication equipment. We also have terminals. All these are attached to one big thing, moves data between the computer and external environment, such as storage, communication equipment, and terminals. That's what the input and output modules do. Examples of input you already know. Things like keyboard, mouse, microphone, all those are input. Output devices, things like monitors, speakers, and etc. So we also have what we call the system bus. This system bus provides communication among processors, main memory, and input and output modules. So that's what the system bus does. And then within the CPU, we have what we call the PC. PC meaning program counter. We also have the ALA, we have the MBALA, we have input, output, ALA, input, and output BALA. And we also have registers separate there, and also the execution unit. So as you can see, the PC meaning program counter, and then the IALA meaning instruction register, MALA means memory address register, and then MBALA meaning memory buffer register. Input and output, ALA meaning input output address register, and then we have the last one, which is the input output, BALA, which is the input output buffer register. With that, let's have what we call the input output modules. As you can see, we didn't talk about that. It also contains buffers, and the system bus, that's a wire more like that, provides communication among the processors, main memory, and the input output modules. We already discussed that. And then we also have what we call the microprocessor. So microprocessor, we are saying that invention that brought about desktop and handheld computing. Those are the inventions that brought about the desktop and handheld computing processor on a single chip. The microprocessor, it is a processor on a single chip. And the fastest general purpose processor. It's a fastest general purpose processor. And then we have multiprocessors. We have each chip socket contains multiple processors and cores. So another thing is graphical processing unit, GPUs. Graphical processing unit. So what does this graphical processing unit do? It provides efficient computation on arrays of data using single instruction multiple data SIMD techniques. It also used for general numerical processing, also physical simulation for games graphic, physical simulation, so that we should be able to see those good graphic for games and different other things. We have to use the graphical processing unit. And then we have computations on large spreadsheets. I think you have heard all that. I've all heard all that now, as we are taking computer science. This is computer system. Digital signal processors, DSPS, digital signal processor, deal with this. Digital signal processor deals with streaming signals such as audio or video, used to be embedded in devices like modems, encoding and decoding speech and video codecs, support for encryption and security. Now, apart from that, we have the system on chip, SoC, system on chip, to satisfy the requirement of handheld devices. The microprocessor is giving way to the SoC, which is the system on chip. So components such as the DSP and GPUs, codec, and main memory, in addition to the CPU, and are on the same chip. So we also have instruction execution, i.e. a program consists of a set of instructions stored in memory. So within that we have the processor. Processor fetches instruction from memory. The processor is to read and fetch take instruction from memory. Processor execute each instruction. So there are two steps within the instruction execution. These two steps are processor reads, fetches instruction from the memory, and the processor execute each instruction. So that's the basic instruction cycle. You can see here we have start, fetch next instruction. After from start we have fetch next instruction, and then execute instruction. Before executing instruction, execute stage to go back to fetch stage, and then hot here, hot meaning to execute. Yeah, so we have the instruction fetch and execute, So what does the instruction fetch and execute does? The processor fetches the instruction from memory. And then program counter, which the PC holds the address of the instructions to be fetched next. Instruction fetch and execute cycle, the way it goes. The processor it will fetch the instructions from the memory, and then the program counter holds address of the instruction to be fetched next, or the next instruction, and then the PC incremented after each phase. PC is incremented, it is increased. The instruction that was being fetched, being increased. That's what we mean when it comes to increment. And then we have the instruction register. Instruction register, what does it do? This one, the instruction register, we can say that I've just seen the dog. Let's concentrate on the dog first. We can see that there is a dog there. First instruction is loaded into the instruction register. So we're saying that the processor interprets the instructions and performs required action. Processor interprets the instruction and perform required instruction. The processor memory, processor input, output, and the data processing and the control. So this stage also consists of 4 stages, which the processor, memory, processor input and output, and data processing and the control. So yeah, so we can see here we have different addresses. We have different characteristic of hypothetical machine, different characteristic of hypothetical machine, and we have the opcode there. We can see the address, can see the instruction format, the integer format, internal CPU registers, and partial list of opcode. We'll explain more on that. So as for now, let us focus on the interlabs. Interlabs. So what do we know by the word interlapped? Interlapped, yeah, by the word itself, maybe you are just being called by somebody when you're in class, you are being interrupted. Same applied to computers. Computers uses an interlapped. Interlapped, the normal sequencing of the processor. Interrupt the normal sequencing of the processor. The interrupt, it will confuse the normal processing of the processor. So in this interrupt, we can say provided to improve processor utilization, and then most input and output devices are slower than the processor. Most input and output are slower than the processor. Processor must pause to wait for device. The processor has to stop. Hey, this is more like you are giving chance to each other. You want to use the bathroom. No. You can use the bathroom first. Well, I'm done. Yeah, something like that. So you can say that provided to improve processor utilization, we also have waste of use of the processor. So within that, we also have what we call classes of interrupt. So what are these classes of interrupt? We can see we have the program generated by some condition that occur as a result of instruction execution such as arithmetic overflow, division by zero, attempt to execute an illegal machine instruction, and reference outside a user's allowed memory space. Another one, we have the timer. The timer, you can say, generated by a timer within the processor. This allows the operating system to perform certain functions on a regular basis. We also have the input and output. So this generated by the input controller, it is generated by an input controller to signal normal completion of an operation or to signal a variety of error condition. And then we also have what we call hardware failure. Hardware failure, we can explain it as it's more like generated by a failure such as power failure or memory parity error. So those are the classes of interrupts. We have program, timer, input and output, hardware, and failure. So, for example, when you want to input something, more like you want to input a USB into your computer, it will go direct, execute to the processor telling that there's something else trying to load here, and then it will give it an opportunity, and then that's all. That's how it goes about it. Yeah, that's all for today. Thank you for watching. See you next time.